Unit 10, Lesson 3, Part 2. The given point is on the terminal side of an angle in standard position. Determine the exact values of the 6 trigonometric functions of the angle. Let's get started. I'm going to remind myself all-star trig class. And then I'm going to use this given information to help me determine where does this point land. Now, if it has a negative cosine value, think of cosine like x's. So if x's are positive, they would be in quadrants 1 and 4. But this has a cosine value like an x value that's negative. Remember when we look at the unit circle, let me grab the unit circle so you can see it. The cosine is the first value and the sine is the second. So cosine values in quadrants 1 and 4, you can see are all positive, and cosine values, the first value, in quadrants 2 and 3 are all negative. So the cosine value is negative. That means I know that it cannot be in quadrant 1 or 4. I'm going to cross those out. It also says that the tangent has to be greater than 0, meaning the tangent has to be positive. All-star trig class reminds me where things are positive. Here, I know in quadrant 3, t, representing tangents, will be positive. So I know right now that my point is going to land in quadrant number 3. So I'm going to draw a point. You can randomly do it anywhere in quadrant 3. Go all the way back to the origin and up to the x-axis. Okay, so I'm going to use these points. So here's my interior angle that I'm evaluating. Cosine represents adjacent over hypotenuse. So from this angle, the adjacent side is 4 and the hypotenuse is 5. A lot of students often ask me, well, what do I do with that negative sign? Remember, this negative sign just tells me which quadrant I'm going to go to, but it can never be related to a length of a side. Now, I know that there are Pythagorean triplets that we are going to memorize as we get into upper level mathematics. One of them is a 3, 4, 5 right triangle. Another is a 5, 12, 13 right triangle. These are common ones. But if you didn't know that, you would say a squared plus b squared equals c squared, 4 being one of the legs. And then you would do this elementary math in order to solve for b. So 16 plus b squared equals 25. I'm going to subtract 16 to the opposite side, take the square root, and yes, there should normally be a plus or minus, but since I am actually using this value to identify this missing length, I know that a length will always be positive. So the missing length is 3. Let's go ahead now and let's identify the sine, cosine, and tangent. Those are the primary trig functions, and then we'll go back and identify the secondary, which is the cosecant, the secant, and the cotangent. And a lot of students do a great job with algebraic portions of this. What they forget to remember is that we are in quadrant 3, and in quadrant 3 only tangent and its reciprocal are positive. So positive for tangent and its reciprocal, everything else will have one negative sign. So sine is going to be a ratio of opposite over the hypotenuse. So 3/5 with one negative sign. That negative sign can go on top, on the bottom, or out front as long as there is one. This reciprocal is going to be a negative 5/3. And you can see this time I put it out front. As long as there's one negative sign, you're good. Cosine is going to be adjacent over the hypotenuse. And we can see that up above as a negative 4/5. And the reciprocal is negative 5/4. Tangent is a ratio of opposite over adjacent, so positive 3/4, and the reciprocal is positive 4/3. Example number 2. The cosecant is 4. Now, in my mind, I know that cosecant and sine have a relationship. I know that the sine of an angle is equivalent. Sorry, I wrote that down wrong. There we go. The sine is equivalent to the reciprocal, which is its cosecant. So sine is equal to 1 over cosecant, which means that if I know the cosecant, and I keep writing this wrong. There we go. If I know the cosecant, I can simply take the reciprocal of the sine. So for example, if cosecant is 4 over 1, that means the sine is 1 over 4. just simply the reciprocal. So I know that the sine is a positive value. Not only is it positive, it's 1 over 4. Sine is like our y. So in these 4 quadrants, sines are positive above the x-axis and sines are negative below. So the sine is a positive value. I'm going to cross out quadrant 3 and quadrant 4 because the y values or sine values are negative in those regions. Also, cotangents are less than 0. That means that the cotangents are negative. Sine and cosecant are going to have the same signs, positive or negative. Cotangent and tangent will have the same signs. So if cotangent is negative, that means that the tangent is also going to be negative. Tangent is also going to be negative. So in my 2 remaining quadrants, I need to figure out which one has a negative sign. So I go back to the acronym All-Star Trig class and I'm focused here. All things are positive here. Here only the signs are positive. So in this position, signs are positive, but cosine and tangent are going to be negative. Nothing is negative over here. So if the cotangent is negative, the tangent must be negative, and that leaves me only one location, quadrant 2. So place a dot somewhere in quadrant 2. Always go back to the origin and straight down or above until you hit the x-axis, creating that right angle with the x-axis. That interior angle closest to the origin will be what I'm going to evaluate. The sine is 1 over 4. Sine is a ratio of opposite over the hypotenuse. Now how do I find this missing length? A squared plus B squared equals C squared. So 1 is a leg. It can be the A or the B. 1 squared plus B squared equals 4 squared. I'm going to take and subtract 1 to the opposite side. 1 squared is 1. So 16 minus 1 is 15. And then I'm going to take the square root. That means B is the length of the square root of 15. And as I shared with you before, you need to make sure that you can't simplify this. So I'm thinking about what perfect squares can I divide into 15 that would help simplify it. The first perfect square below this would be 9. Doesn't help me simplify. 4 doesn't help me simplify. And 1 can divide into anything. It's not simplifying. So this is going to be the square root of 15. Before I begin, I want to focus on where is this terminal angle. And really when we say terminal angle, we're referring to is where is the endpoint. This endpoint lands in quadrant number 2. In quadrant number 2, only the signs and its reciprocal are going to be positive. So positive sign and its reciprocal. Everything else will be negative. Okay, the sine of this angle would be opposite over hypotenuse. So 1/4, and its reciprocal is 4 over 1. And we could have achieved that by just looking up above. The cosine will be the adjacent side over the hypotenuse. So square root of 15 over 4. Now when I take the reciprocal of this, yes, I have -4 over the square root of 15, but then I have to rewrite it in proper form. So -4 square root of 15 over 15, and it cannot be reduced. Tangent is going to be opposite over adjacent. Opposite over adjacent, so 1 over the square root of 15. Again, proper form would leave us with -1 square roots of 15 over 15. And the reciprocal of 1 over the square root of 15 would be negative square root of 15 over 1. Our third and final example from part 2 of lesson 3. I'm always reminding myself of All-Star Trig class. So I know that the tangent has to be negative. Well, where is the tangent's negative? Here all things are positive, so I can go ahead and cross out quadrant 1, and here we're told that tangents are positive. So all things positive, tangents positive. It cannot be in quadrant 1, and it cannot be in quadrant 3. Those options are out. What else do I know? When it's choosing between quadrant 2 and quadrant 4, I'm also provided with this information. I'm told that the angle that I'm going to choose, so where does this terminal angle land, will be between pi over 2 and 3 pi over 2. That's 90 degrees and 270. So it's going to be between here and here. And that only leaves me with the option of quadrant number 2. So let's go ahead, put 1 dot into quadrant 2 and go back to the origin. Remember, we always go down to the x-axis. Common mistake being that students want to go to the y-axis. Always back to the x-axis. And the angle in which we are going to determine the 6 trigonometric functions will come from that interior angle closest to the origin. Okay, what do I know here? I know that tangent represents the ratio of opposite over adjacent. So opposite over adjacent. And I want you to think to yourself, what about that negative sign? Because that's often a question students have. That negative sign allows us to cancel out quadrant 1 and quadrant 3. The negative sign cannot be used to describe the length. Now 5 and 12, I already know that missing length is a 13 because I've memorized 2 of the most common Pythagorean triplets, 3, 4, 5 and 5, 12, 13. But if you didn't know that, you would use the Pythagorean the Pythagorean theorem, knowing that A and B represent lengths of the legs and C is the hypotenuse. So 5 squared plus 12 squared equals C squared. 125 plus 144 equals C squared. 169 equals C squared. Should have a plus or minus, but because it's a length, we end up with simply 13. Let's now evaluate the 6 trigonometric functions. So we have a terminal angle landing in quadrant 2. In quadrant 2, only the signs are positive and it's reciprocal. Everything else is going to be negative. So sine opposite over hypotenuse is the ratio. Opposite of the interior angle here I'm evaluating over the hypotenuse, and then 13 over 5. The cosine is adjacent over hypotenuse, and the reciprocal. The tangent is opposite over adjacent, and the reciprocal.